Module 6.4 brings us to a new application of the derivative topics that we've been covering so far. In this case, ultimately the question we're going to be interested in answering is how much should we charge for a product? Should we increase price? Should we decrease price? What effect is that going to have on demand or on revenue? So suppose that price P and the demand X for some product are related by the price-demand equation, X plus 500P equals 10,000. We can take this given equation and solve it for X. So we just subtract the 500P from both sides, which would give us X equals 10,000 minus 500P, or factoring out the 500, we would get 500 times 20 minus P. Here, both X and P, so demand and price, both represent non-negative values. So demand can't be less than 0. Price can't be less than 0. So we can start off by stating that 0 has to be less than or equal to X, and 0 has to be less than or equal to P. So now what we want to find are the upper bounds for those two inequalities. So what's our largest and smallest possible values for demand and price? So in order to find that, what we do is just set the other variable equal to 0. So for instance, we would take X equals 500 times 20 minus, and then in place of price, we'll plug in a price of 0. So essentially, if we were giving our item away for free, so charging people no money for it, then we would have a demand of 500 times 20, or 10,000. So X is going to be bounded between 0 and 10,000. And if we set X equal to 0, we would have X equals 500 times 20 minus P. So what's the maximum price, or the price that we would reach that now nobody at all would want to buy our product? This would give us 0 equals 20 minus P, or P equals 20. So our price point has to be somewhere between 0 and 20, because at 0 we're giving it away for free. At $20 there's 0 demand. Nobody wants to purchase our product. And then demand is going to be bounded between 0 and 10,000. If we're charging $20, nobody's going to want to buy it. If we're giving it away for free or something very, very, very close to free, demand is going to be around 10,000 units. So elasticity of demand is what this section is all about, and it can be calculated as the opposite of the relative rate of change of demand So relative rate of change of demand divided by the relative rate of change of price which can be represented as the opposite of the derivative with respect to P of the natural log of f of P. So f is that demand function that's in terms of P, divided by the derivative with respect to P of the natural log of P, so the natural log of our price. So differentiating the numerator and denominator separately, we get negative 1 over f of P. And since this is an iteration of the chain rule, we've got a composite function here. We get 1 over f of P times the derivative of f of P all over 1 over P. So a little bit of algebraic simplification. We can rewrite this as negative f prime of P over f of P times P over 1 gives us negative P times the derivative of that demand function divided by the original demand function itself. And then this formula is what we're after. So these steps are just to derive this formula that we have for elasticity of demand. So elasticity of demand, where price and demand are related by this function x equals f of p. So x equals some function with p as the independent variable. Then we can define elasticity of demand, E of p, as negative p times the derivative of that demand function divided by the original demand function. So this is the formula that we'll be applying for pretty much all of the problems in this module. So here, price and f of p, which is really just the same thing as x, our demand, are again both non-negative values. And the derivative of our demand function is always going to be negative, since demand is typically decreasing. So since the rate of change of our demand function is decreasing, that's always going to come back with a negative value. So it's always decreasing as a function of price. So we have that negative sign out front, ensuring that E of p will always be a non-negative value. So just a little bit of discussion of why there's that negative symbol out in front. Just helps to ensure that whatever value we come up with for elasticity should be a positive value, or at least a non-negative value. So as you're making calculations, there's kind of a red flag. If you ever are calculating an elasticity and you get something less than 0, then you should know automatically that something went wrong with your calculations. Elasticity, this value E of p that we're generating, is always going to be a non-negative value, so 0 or larger.